We'll now talk about the history of computers, and I've decided to split this history into two parts, before World War II and after World War II. Basically, the main reason is that computers changed the world after World War II. So, in the period before the war, I've selected four objects that will be interesting to study. The four objects are the abacus, the Antikythera mechanism, the Pascaline, and Charles Babbage analytical engine. So the first one, the abacus, you obviously probably know. You have seen it before. It's a very old object dating from 2000 BC, or that's what's estimated. It comes from Asia. It's composed of a lot of beads that are on different rods. So you have beads here that you can move. So if you have a rod with the beads, you can move the bead from the bottom to the top. And this symbolizes either present or not, or 1 or 0, or you just count the number of beads at the top, right? So in this way, you could represent numbers. And by manipulating your numbers, you sort of have the memory in the abacus, and this can help you perform the calculations. Sometimes in some abaci, you are allowed 3 positions. You can have bottom, middle, or top. But an important artifact, an important aspect is that there is a limited number of positions. It's not allowed to move the bead continuously from the bottom to the top. That's not allowed. You're only allowed to have it in a selected number of positions. So that's what makes the abacus digital. People argue about this a bit, but I think anyone defending that the abacus is not digital would be wrong. The next object is a completely fascinating object. It's called the Antikythera mechanism. It dates from the 1st century BC. It was found in the sea off of Greece, and you can see it now in the museum in Athens, in the National Museum. It's a truly fascinating object. Basically, it's composed of gears that you can see one here. It wasn't found in a very good condition, and it took a long time to realize what it was. But it's composed of gears, and there are many of them and imbricated. And those gears perform calculations, and actually they perform astronomical calculations. So the kind of astronomical calculations you might want to do is compute the next eclipse, or for the Greeks, compute the next Olympic Games. And it's suspected that this machine actually did that. So you can compute the tides, you can compute the position of planets, you can do all those things with that object. So really, it's a clock. It doesn't tell you the time, but it tells you about position of objects in the sky, their relations to each other. And I think that's truly amazing, because if you had asked me before I heard of this object, when were clocks were invented, I would have guessed somewhere around 1500, and never at the time of the Greeks, a full 1500 years earlier. So if you ever have a chance, go look at it, and the second best thing you can do now is go to the Wikipedia page and read a bit about it. The next object is the Pascaline. So the Pascaline was invented by Blaise Pascal, a famous French philosopher, in the 1600s. So what is it made of? Well, you see that there are wheels here and more display wheels here. So on those display wheels are numbers, and the position of the wheel indicates the strength, the importance of that number. So you would have units here, tens, hundreds, thousands, tens of thousands. Okay, and the different gears here interact so that if you turn this one enough times, this one will make progress by 1, and so on. Okay, so with this object, you can perform basic arithmetic operations like addition, multiplication, subtraction, and division. You can do things like this. Now, you could think that you could already design such a machine yourself. Well, that's probably true, but you have to be aware of one complexity. The complexity is when you do things like 999 plus 1. So if you do this, you realize that all the wheels, or at least the first 4 wheels, have to turn because you go all the way to 1,000. And the way I described it, a full turn of this wheel only affects this one a tiny bit, and a full turn of this one affects this one a tiny bit, and a full turn of this one affects this one a tiny bit. So what I mean by this is that the force you apply here gets lost easily when in the transmission. It's each time divided by 10. So the difficulty is for this machine, with the manufacturing standards of the time, not to block when you perform something like that. Okay, so the mechanism that Pascal had to design for this also made the machine quite digital. There were a discrete set of positions that were allowed, and suddenly it switched to the next position. And the switch would not really be more difficult whether you're doing 1 plus 1 or 999 plus 1. Okay, the next object is the true revolution that was missed. It's a sudden realization that all those objects could be raised to another level of power. And this revolution was completely missed because this object, the analytical engine, an invention of Charles Babbage in the 1850s, was never actually built. So what he did was just design some plans for it, and he never got people to back the construction of it, and his design would have worked. We've realized later that we could have built it and it could have worked. And the only person that really got interested in this object is Ada Lovelace, who started writing programs, right? So let me explain what this object was. Well, what Charles Babbage started to do was to build something like the Pascaline for addition, and he called that the addition engine. He started constructing something like Pascal did for multiplication, and he called it, give it another name, and so on. So he constructed many objects, and after a while he realized, wait a minute, I could just build one object, which I'll call the analytical engine, that will simulate all of Pascal's object, or all of those basic operations. So basically, my machine, you could set it up in such a way to simulate another machine if you want. So suddenly he builds those calculators at another level, where he builds, if you want, a meta calculator that can perform any calculation that you might want to do. And that's really the invention of the computer. It's really going from the calculator to the computer. At least it's the leap of understanding that happened with Babbage. And for this machine, you have to write for the first time programs. So you have to write, if you want, settings for the machine, positions they have to place themselves in, so that they can simulate a certain calculator. Okay, so the programs are essentially settings for the machine that allow it to simulate another machine. And the first programs, as I said, were written by Ada Lovelace. So Babbage had invented a new machine, the computer, but this was just lost to humanity for 100 years. And we'll see that with World War II, a lot of progress was made in building computers that basically changed the world after that.